Well, here's our standard car door lock actuator, runs on 12 volts. It has both push and pull capacity, rated at about 8 pounds. The total distance is about a 3/4 of an inch throw. Very handy device, available from a lot of sources for about $5. When you buy them, be careful. Some of them, although they look very similar, work smoother than others. Here's the device on an ohm meter showing it reads around 2 ohms. So a 12 volt device with 2 ohm resistance is going to draw about 6 amps. Now our whole project here is to find interesting ways to run this device on components rated at as little as 1 amp. So introducing our cast of characters in this little project is a 1 amp 12 volt wall wart. It's a very common size, very available, and very inexpensive. To drive the circuit, we've selected the TIP112 transistor. This is a Darlington device with a gain of around 1,000. Very easy to drive with any microcontroller source. The current rating on this device is 2 amps. We've chosen this small double-pole, double-throw relay to reverse current in our device. Notice that this is rated at 2 amps. And finally, the hero of the show here is a 15,000 microfarad capacitor rated at 16 volts. These were available for around $2. Here's our circuit for doing this. Got a 12 volt feed here. Comes through a 100 ohm resistor, 1/4 watts fine. Charges our big old 15,000 microfarad capacitor. Found these for a couple of bucks each at AliExpress. Ours are rated at 16 volts, which is a perfect match here. That provides the energy through the relay here. Coming through this, goes one way through the device, and then back out here. When this transistor is activated, this sucks current through this capacitor and activates the device over here. Now, normally you put about a 200 millisecond pulse, although if you got a scope, you might keep an eye on this and see how long it takes before this capacitor drains, because anything longer than that won't help. So that's just how to activate the device. This transistor activates is hooked to the coil here, which is 12 volts. When this is on, it switches polarity, because the normally closed goes to normally open to normally closed. And this is your standard double pole, double throw relay configuration, where you get power either way, but activating it simply switches the polarity. Now the power comes through here, goes the other way through here, come back here, down through here. Now here's an important consideration. We've specified using a relay that's rated at 2 amps. Our device takes 6 amps. What do? Well, you activate the coil, wait a few milliseconds, we're doing like 5 milliseconds, then kick it for the 200 millisecond power. When that's done, wait 5 milliseconds and then turn off the coil. Because the contacts are never switched while they're hot, the 2 amp rating is more like a 6 or 8 amp rating. This is standard on any relay or any switch. If you only switch when it's off, you can go to a much higher current rating. So here's what the signals look like on our scope. The center pulse here is our main activation pulse that's 200 milliseconds long. The bottom pulse is the relay activation. Notice the relay is activated before and after the power pulse. This allows us to run 6 amps through what's called a 2 amp contact relay. Top one here is the voltage on our 15,000 microfarad capacitor. When it's activated, it starts to discharge. Now notice the curve here. The curve discharges and then starts discharging more slowly. This is because the motor inside is running. creating back EMF. However, at this point here, it must have hit the end of travel. At that point, there's no more back EMF, and it discharges more quickly. Now, in a real situation, since this one wasn't under load when it was measured, this point would tend to move farther over here. So here's how this works in real life. This is our entry door. It's activated by the type of circuit we designed and responds to a remote transponder that we carry with us at all times. The transponder, by the way, is motion sensitive, so it turns off when it's just sitting around. So that's a wrap. There it is. And we hope you find this information useful in your next project.